Uh, Good morning, sir, and good morning, classmates. Our report today is about limit analysis of slabs. So, next slide is theory of plasticity. Theory of plasticity is concerned with the strength and deformation of rigid plastic or elastic plastic materials. A rigid plastic material is defined as one that remains undeformed until yield stress is reached, after which deformations can occur without an accompanying stress increase. So, dito, di ba, di naman natin matatawag na plastic mismo si concrete. Kasi mas matigas nga siya. Pero, si concrete kasi, pwede siyang bumaluktot muna bago siya tuluyang masira. Plasticity, also known as plastic deformation, is the ability of a solid material to undergo permanent deformation, a non-reversible change of shape in response to applied forces. So, yun nga, di ba, parang sa bakal din, pagka binaluktot mo yung bakal, hindi na siya bumabalik sa dati niyang anyo. So, ganun din si concrete, syempre, ginawa niya parang lasting na bumabalik sa anyo pagyayari mong ibaluktot. So, ayun nga ang plastic deformation, hindi na siya bumabalik sa dati niyang anyo. Yield line theory. The yield line theory thus is an ultimate or factored load method of analysis based on bending moment on the verge of collapse. At collapse loads, the slab begins to crack as they are mostly under-reinforced, with the yielding of reinforcement at points of high bending moment. With the propagation of cracks, the yield lines are developed gradually. So, yun nga, yung yield lines kasi, yun yung parang dun mahati yung slab mo sa, kunwari, masyadong malaki yung load na natatanggap niya. So, yung yield lines, parang dun mo malalaman kung paano mahati yung slab mo. Yun nga, pag di niya nakakaya yung load na dinadala niya. So, eto, basic principles sa may one-way slab. Diba, sinasabi dito na a slab which is supported by parallel walls or beams. So, sa one-way slab, dalawang side lang niya yung merong support. So, ang tendency ngayon, pagka may load na siya in-applyan mo siya ng load, ang gitna niya yung mahina. Kasi, yun nga, hindi siya supported sa all sides. So, next is two-way slab. A slab which is generally supported on all sides of walls or beams. So, dito, mapapansin nyo yung pagkakurba ng two-way slab is para siyang nagiging triangle o yun nga, parang triangular prism na ganun baliktad. So, kasi, yun nga, apat na sides niya yung meron. So, ganyan siya bumaluktot pagka na-apply ng load. Yield lines analysis. The first requirement of the yield line analysis is to assume possible yield patterns and locate the axis of rotation. So, din sa yield lines analysis, ang pinaka-goal natin is hanapin yung yield patterns and yung axis of rotation. So, yung yield patterns, yun nga, hanapin natin kung saan siya mabibiyak yung ating slab. So, yung axis of rotation, mamaya is i-explain. It is worth mentioning that other cases of two-way slabs will have sufficient number of real or plastic hinges to form a mechanism while they will be on the verge of collapse. So, ano nga ba yung plastic hinges na yung sinasabi? So, next slide, may explain natin. So, what is plastic hinge in plastic analysis? Such regions behave like hinges rotating under constant plastic moments and are termed plastic hinges. Failure of the structure is brought about when the number of plastic hinges is sufficient for the structure or part of it to become a mechanism, or when one or more of its hinges fail through excessive deformation. So, dito, yun nga, parang sinasabi nga kasi hinges, parang siyang bisagra ng pinto. So, parang yun ang nagiging bisagra natin. So, din kasi sa plastic hinges, pagka sa slab, siya yung parang nasa pinaka-side ng slab. Kasi siya yung mag-a-act na hinge dahil nga yung slab mo is babagsak siya pababang ganun. So parang andito siya yung hinge. So ayun, yun nga yung parang kumakapit kumakapit na gano'n para pag bumaba siya, yun nga, parang pabukas na gano'n na pinto. So, next slide is the yield lines will divide the slabs into a number of segments which will rotate as rigid bodies about the respective axis of rotation. So, yun nga, yung yield lines kasi, yun yung parang humahati nga ng slab. Pagka masisira na siya, so parang yun nga yung mga portion ng, nagiging portion siya ng slab. Yield line. The two terms positive and negative yield lines are used in the analysis to designate the yield lines for positive bending moments having tension at the bottom and negative bending moments having tension at the top of the slab respectively. So dito, ayun nga, pinapakita sa image na nahati yung slab natin ng yield lines. So sa axis naman, yun nga, nakapaikot siya. Hindi, base sa pangalawang figure, yun nga, ang axis of rotation niya is nasa line 1, 1, 2, 2, 3, 3, at 4, 4. So, yun nga, kung saan nakalagay yung mga support niya. So, dito sa dalawa na to, positive and negative yield lines. So, yung sinasabi dito na sa pag positive ay siya yung nangyayari sa ibaba ng slab. So, di ba may tension nga doon kasi nahahati nga ganun yung pag bumaba yung slab, nahahati yung slab na ganun. Tapos, syempre, yung force na nasa ilalim niya is under siya ng tension. So, kaya nabibiyak siya agad sa ibaba, bago sa ibabaw. So, sa negative naman, sa may malapit siya sa may support o sa may mga gilid ng slab. So, syempre, yung baba, parang ano siya, parang fix siya. Pero yung taas nun, under din siya ng tension kasi bababa nga yung slab, so mababanat din yung nasa taas. So, yun lang po yun. Next slide is, yun nga, ito nga, yung axis of rotation. The axis of rotations will be located along the lines of support or over columns if provided as point supports. So, yun nga, pagka yung axis of rotation, yung malapit siya sa edge pagka yun nga, kunyari sa may beam, yung pinaka kung saan sila nagdidikit, yun yung hinge. Doon meron hinge. So, doon siya kakapit pagka pababa siyang gano'n. So, yun nga. So, ito naman, ang sumusunod is, the following are the guidelines for predicting the yield lines and axis of rotation. So, ito nga po, may mga parang guide tayo para malaman kung saan pwedeng sumulpot sila, yield lines and axis of rotation sa ating mga slab. So, number 1, yield lines between two intersecting planes are straight lines. So, kung matatandaan nyo sa example natin kanina, pagka one-way slab, ay dalawang side lang niya may support. So, ang tendency nun sa gitna is, syempre, parang pa letter U na gano'n. So, straight siya sa gitna. Straight yung yield line natin. So, ang next is, positive yield line will be at the midspan of one-way simply supported slabs. So, yun nga. Sinasabi nga lang din dito na pagka one-way slab, automatic, nasa gitna na agad yung yield line niya. Tapos, next is negative yield lines. Next is number 3. Negative yield lines will occur at the supports in addition to the positive yield lines at the midspan of one-way continuous slabs. So, yun nga, yung sinasabi natin na magkakaroon siya ng negative yield lines pagka dun mismo sa kadikit siya ng support sa may slabs, yung pinaka parang dugtungan nila. So, negative yun. Yield lines, next is number 4, yield lines will occur under point loads and they will be radiating outward from the point of application of the point loads. So, yun nga, kung saan syempre mag-a-act yung pinaka nabibigatan, kung saan siya mas nabibigatan, nandun yung yield line. So, sa one-way slab, sa gitna siya mas pinaka nabibigatan dahil yun nga yung parang pinakamahinang part niya. So, number 5. Yield line between two slab segments should pass through the point of intersection of the axis of rotation of the adjacent slab segments. So, yun nga, pagka yung yield line daw ay nasa gitna ng dalawang slab, so kahit may support siyang ganun sa gitna, syempre yung yield line mo, nasa gitna siya mismo nun dahil ang sinusuportahan lang naman nung support mo is yung parang pinaka pinagpapatungan ng slab mo. So, syempre sa may bandang taas medyo mahina. Dahil nga, di ba dun may nangyayari ding tension dun. Pag bumaba yung slab mo, parang nabibiyak sa gitna ng support. So, yun nga po. Next slide is number 6. Yield lines should end at the boundary of the slab or another yield line. So, ang yield line mo kasi, kunyari pagka one-way slab, ang yield line mo side by side. Yung sa side na walang support. So, pagka naman two-way slab, ang mangyayari ngayong yield line mo is mula dulo hanggang dulo. Basta ganun. Lagi silang dulo hanggang dulo. Kahit may support doon sa may side na yun. Pagka two-way slab. So, next is 7. Yield lines represent the axis of rotation. So, yun nga. 'Di ba? Ang yield line natin is humahati ng slab. So, minsan kasi ano 'yan, pagka two-way slab naka-focus sa gitna. Sa gitna mismo nung slab yung parang pinakakahinaan niya. So, ang yield lines parang ano siya doon eh. Parang doon siya nagtatagpo sa may gitna. So, pagka nagtatagpo siya sa gitna, malalaman natin agad na yung axis of rotation niya pwede siyang magkaroon ng hinge doon. Kunwari, matibay yung part na isa sa gitna ng slab, tapos may isa yung mabigay na dahil nagka-crack na. So, kahit hindi siya yung pinaka-support, pwede rin siya mabiyak na pag ganon. Hindi naman lagi sa support na lang lagi nangyayari. So, number 8 is, supported edges of the slab will also act as axis of rotation. However, the fixed supports provide constant resistance to rotation, having negative yield lines at the supported edges. On the other hand, axis of rotation at the simply supported edges will not provide any resistance to rotation of the segment. So, pinapakita lang dito, kunyari sa two-way slab, syempre yung axis of rotation niya nasa edge nung support mo tsaka nung slab mo. So, yun nga, pag ganyan, syempre may kinakapitan pa siya. So, pagka simply supported slab ka, yung pagka one-way slab ka, syempre yung may mga side ka na walang support. So, hindi niya kayang i-resist yung rotation. Syempre, bigla na lang babagsak yun dahil alam naman siyang support doon. So, number 9 is last. So, axis of rotation will pass over any column support if provided, whose orientation will depend on other considerations. So, yung axis of rotation natin, di lang naman siya basta hihinto na pagka may support, hindi lang siya basta hihinto ron. Parang, kunwari kasi yung natumba yung slab mo sa kabila, parang ang tendency nun, parang may mangyayari ding reaction dun sa kabilang slab mo. So, yun lang yung pinapakita nun. Pag bumaba kasi isa, syempre, parang mas nagagalaw din kasi yung kabila. So, parang nagkakaroon din ng rotation dun. Kahit hindi masyadong kita ng mata. Thank you po. Next reporter na po.
Good morning, sir. Good morning, classmates. We are the reporter number 4 and our topic is limit analysis of slabs. So, ano nga ba yung limit analysis of slabs? The computational tools presented align closely with the traditional method of designing and assessing RC slabs. The traditional method for assessing slabs has been Johansen's yield line technique, which as an upper bound method relies for its accuracy on the ability of engineer to postulate a realistic collapse mechanism. So ano nga ba yung Johansen's yield line technique na tinatawag? So yung yield line technique is a well-founded method of design reinforced concrete slab It uses yield line theory to investigate failure mechanism at the ultimate limit state. Because of yield line method, low amount of steel can be used as compared with the elastic method of steel. Slab uses the discontinuity layout optimization or DLO method to robustly and efficiently computerize the yield line technique, automatically identifying collapse mechanisms that have corresponding collapse loads that are very close to theoretical solutions. So ano nga ba yung DLO method? So DLO, which is an engineering analysis procedure that can be used to directly establish the amount of load that can be carried by a solid structure prior to collapse. Using DLO, the layout of failure planes in a collapsing structure are identified using mathematical optimization methods. It is assumed that failure occurs in a ductile or plastic manner. In contrast, the traditional method for designing slab has been Hillerborg's strip method, which as a lower bound method provide a set of equilibrium moment fields that may be used to size and position the reinforcement. So the Hillerborg strip method is the traditional method of designing slab. It encourages the designer to vary the reinforcement in a logical way, leading to an economical arrangement of steel as well as safe design. It is generally simple to use, even for slab with holes or irregular boundaries. Ramsey-Monder Associates or RMA, Equilibrium Finite Software. So ano nga ba yung RMA na yung sinasabi? O yung EFE? Equilibrium finite element formulation is an up-to-date exposition on hybrid equilibrium finite elements, which are based on the direct approximation of the stress fields. The focus is on the derivation and on the advantages that strong forms of equilibrium can have, either when used independently or together. These elements solves two important problems of concern to computational structural mechanics. A rational basis for error estimation, which lead to bound on quantities of interest that are vital for verification of the output and provision of outputs immediately useful to the engineer for structural design and assessment.